is putting up a limit there on the depth of the beam. So d by SV is putting the limit on the depth of the beam. You cannot increase it beyond a certain value, or otherwise shear forces will along the depth will increase to such a limit that they will not be effectively, this tie-up will not behave to resist the shear forces. All the shear forces that are transferred, I told you, are transmitted at an angle. Now if the depth increases, this shear force, each tie-up may be coming under two layers of shear forces acting on it, crossing at multiple points. So that tie-up will have to take a lot more shear load then. So it's not an effective means of doing it. So we do not increase it beyond a depth, beyond a limit. For that, I just told you, we provide then the side reinforcement. And when we provide the side reinforcement, इनके बीच में यहाँ पर एक और bar, there is another bar. So the effective depth then is decreasing. तो वो एक्स्ट्रा लोड कौन ले रहा है? साइड reinforcement ले रहा है. Now, how did the code get this equation? What is 0.87 into Fy? अभी हमने पढ़ा, it's the design strength, tension strength of steel. वही पढ़ा ना? It's design. This much you get the design tension strength of steel. Then ASV into D by SV से क्या मिला? All the shear forces are transmitted at. Do you know what is the shear resistance of a steel bar? If you check its shear resistance, it's at 1 by under root 3 around of F1. The shear resistance of a steel bar is 1 by under root 3 of F1. So how much is this? 1 by 1.732. कितना बन रहा है वो? कितना बन रहा है? अगर आप चेक करोगे ना एक स्टील बार को फॉर शेयर स्ट्रेंथ, ये कितना बन रहा है? 0.57. This is shear strength. 0.57. ये even this is rough value that I am giving you. 0.577, it may vary from 0.5 till 0.7 Fy, the shear resistance of a single steel bar. Now 0.87 Fy is greater than this, the design tension strength. Then it's being multiplied by D by SV. Now D by SV then should be lesser than the value, it should be the lesser value. Then you will get around 0.577 Fy. So D by SV, D should be less and SV should be greater. So an effective shear resistance will be provided only when you have D less than SV. But now if you keep the shear spacing around 300 mm and if your D is 400-500 mm, it's still not effective. But it's being allowed by the code, because code then keeps a limit, achieves the limit by placing another thing, that is ASV. Now this is based on, this is a research work that has been done from which this formula has been obtained, based on the empirical models that have been generated from the research experimentation. Now ASV, what is ASV? It's dependent on the diameter of the ASV is this diameter of single style. DS is the diameter of single style. This is ASV. So now if you are, we now get from this equation ASV, because D is known, SV we fix. हमें क्या मिलता है, BU is known, we get ASVG. From ASV then you fix the diameter of the shear reinforcement from this equation. ASV is equal to pi by 4 into ds square. तो लेकिन अब उसमें भी लिमिट है, आप shear reinforcement का diameter कितना रख सकते हो. If it's I'll check the clause on that, but what you can do is the minimum diameter of the shear reinforcement, we do not provide it normally now below 8 mm. 8 mm से नीचे आप shear reinforcement का बार you do not provide it. Minimum is 8 mm. Even if you are getting this कि आपको 6 mm ही चाहिए या 4 mm ही चाहिए, but still you have to go for minimum 8 mm, because that below 8 mm bar, it's not ductile, it's brittle, it fails abruptly. So we provide minimum 8 mm dia bar for shear reinforcement. तो हमारे स्टाइल्स जो है ना वो मिनिमम 8 mm के होने चाहिए. Now what is the limit on the tension reinforcement? उसका dia of the bar टेंशन reinforcement का डाया हमने क्या लिखा, DL और YL. What is its dia minimum in a beam? It will not be given here, but we do not go below 10 mm. So normally we do not go below, so it should be greater than or equal to 10 mm. This is again from convention, not from code. Code does not mention this. So 8 mm का भी हम longitudinal bar नहीं देते. We usually go with minimum 10 mm. 12 mm in a beam is good enough. 16 mm usually हम दे देते हैं. 20 mm where the cases are जहाँ पर load बहुत ज़्यादा है. 22 mm भी जाते हैं, 25 भी जाते हैं in a beam usually. तो 10 mm से नीचे हम नहीं देते बार डाया longitudinal. Now in compression as well you do not provide below 10 mm. Even if the compressive loads are less, then we'll wind up this lecture. In the next lecture